Oh, yes, we are. We are back. What happened? We are back on the chain gang, boys and girls, because today we are talking about the chain rule. Everybody loves the chain rule. Good morning, good afternoon, good evening. We are back and we are better than ever. Now, we've been having fun with taking the derivatives, and they've been fairly straightforward, and things are going to get a little dicey when we have composites of functions. Remember g of f of x right here and here? Sometimes, when we take the derivative of these, it can be helpful if we use just a little bit of substitution here. Or rewrite them a little bit. So if we have y equals x squared plus 3x all to the fourth power, we could rewrite it as y equals u to the fourth power if we let u equal the function within the parentheses. Okay? And that will make our life easier, maybe. I'll let you be the judge when taking the derivative. And when we have it in this form, or whenever we have a function within another function, then we are going to use the chain rule to find the derivative. Here is the chain rule from your formula sheet. If y equals g of u, where u equals f of x. Well, what does that mean? Well, if we look back at here, we had y equals x squared plus 3x to the fourth. So let me write that. Y equals x squared plus 3x to the fourth. Yes? So the u is that thing. Okay? And the y is really the parentheses to the fourth power. We just think of it as the fourth power. Okay? And then they say here u equals f of x. Well, that's the function within inside. Then to take the derivative with respect to x, we first take the derivative of the outside function, blah to the fourth power, and multiply that by the derivative of the inside function, the u, the derivative of x squared plus 3x. Okay? It's really important, obviously, when we have complicated functions like this one. Here's another way to look at it. If we have y equals some function to the nth power, then the derivative is equal to your regular old power rule. N comes out front, n to the n minus 1, and look, nothing happens to the function inside. It just stays there. And you multiply that by the derivative of the function inside. All right, let's do a couple examples, enough yakking about it, okay? So we have y equals x squared minus 2x to the fourth, and we have this for our reference. dy dx is equal to dy du. So what they're saying there is, let's just, for temporarily, let's think of the inside as u. So we're going to take the derivative of the outside using the power rule. So this 4 comes out in front, and I'm just going to leave the parentheses blank for now. Actually, I'll put a u in there. Let's just say the u is in there. So it's 4u cubed, right? Subtract 1 from the exponent. But what's the u equal to? The u is equal to x squared minus 2x. So it just stays in there. And I'll write this u down here, times the derivative of u with respect to x. Well, u is equal to this. So now I'm going to take the derivative of the inside, and look, it's multiplication times that. What's the derivative of x squared minus 2x? Well, it is 2x minus 2. And you're done. This was A. Okay? I like to think of it as the derivative of the outside, where the outside is the function on the outside of the parentheses. Yes, the blah to the fourth power. Well, if I have blah to the fourth power, yes, then the derivative is 4 blah to the third, yes, times the derivative of blah, and I'll just write that as blah primed. Okay, so that's how kind of a way that I have thought about it that just makes it a lot easier in my mind. The derivative of the outside times the derivative of the inside. Okay, so let's do B. Well, this is no good. I can't take the derivative like this. I don't have a power. I'm going to need to rewrite this function. So I'm going to think of this first of all as y to the 1 minus 2x, or I'm sorry, y equals 4 over 1 minus 2x to the 1/2 power. And then I'm going to rewrite that as 4 multiplied by 1 minus 2x to the negative 1/2 power. Okay, so now I'm going to move over here so I have a lot of room. dy dx equals the derivative of the outside function. The outside function is really just the exponent negative 1/2. So I'm going to use my power rule. Derivative of the outside, negative 1/2 times 4 is negative 2 times, now this is my u in here. I'm not going to do anything to it, so I've taken, well, I haven't finished yet. Now I have to subtract 1 from the exponent. Negative 1/2 minus 1 is negative 3/2. Okay, so I have now taken dy du if I think of this inside as u, the derivative of y with respect to u. I don't like to put the u in there and then resubstitute it. It just takes too long. Okay, so now times the derivative, times the derivative of u with respect to x, the derivative of the inside. Well, what's the derivative of 1 minus 2x? Well, the derivative of 1 minus 2x is negative 2. Okay, now before I didn't simplify this because there's nothing to simplify, and we take the derivative to be able to find the slope of the tangent to the curve. And if I have a value of x, I can easily substitute x in here without having to expand this and multiply by this. That's just a mess, so just leave it alone. But if I have something like this, a negative 2 times a negative 2 is a positive 4, and we are done. Okay, I guess we should also say, okay, that this should be written, or could be written as the 4 over the square root of 1 minus 2x cubed. And that's just bringing this to the bottom and rewriting it as a radical. Okay, last example, a very complicated one. Okay, so not very complicated, but just lots going on. So I'm going to rewrite this as f of x is equal to 2x plus 3x plus 4x cubed, all of that to the 1/2 power since all of it is under the square root. So I'm really going to have a double chain rule going on because I have an outside function here, then another outside function here. Okay, so the derivative would be derivative of the outside. Bring the power rule, 1/2 up front. So 1/2 times, I'm going to leave the inside alone, 2x plus 3x plus 4 cubed. 1/2 minus 1 is to the negative 1/2. Okay, so now I've taken the derivative of the outside. Now I have to take the derivative of the inside and multiply it. Okay, so the derivative of 2x is 2 plus, oh my gosh, I have my own another little chain rule in here because 3x plus 4 cubed is a function within a function. So again, I have an outside function. The cube here is an outside function. So I'm going to bring that out in front of this parenthesis. Plus 3 times 3x plus 4. Not doing anything to it because it's the inside. 3 minus 1 is 2, so that's going to be squared. Okay. And now I have to take the derivative of this inside. Right here, 3x plus 4. And the derivative of 3x plus 4 is 3. And we should clean this up a little bit and say, okay, 3 times 1/2 is 3/2. This negative becomes a square root on the bottom, and that'll make it easier to evaluate if we have a value for x. So that would be the square root, moving this whole thing down low, of 2x plus 3x plus 4 cubed. Okay, so that's all that. Okay, and I've already taken care of this 3. So now we just have to put this thing up on top. So that's 3 times 2 plus 3 times 3x plus 4 squared, close parentheses. Okay, that was really complicated. If you need to, you should rewind a little bit and follow each step. It's just always the derivative of the outside multiplied by the derivative of the inside, and we had to repeat the chain rule. Okay, that is it, and I am out!